Welcome to Lesson 9 of Module 1 and 2 for Investigating Science. For our Do Now today, we're going to look at this scenario. An ecology teacher has asked her students to undertake a fieldwork study of organisms present within the school grounds. So for this investigation, I want you to identify the following: quantitative data that will be collected, qualitative data that will be collected, and how will you represent that data? So how will you record it and how will you store it? Complete this activity now. For today's activity, we're going to be looking at recording and analysing data with a bit of a bootcamp session to start off with, and looking at how does the collection and presentation of primary data affect the outcome of a scientific investigation. So we're going to be looking at different methods and conventions that we use to display observations, and then looking at outliers as well. So one of the ways is tabulation. It's the most efficient way to record quantitative data. It's systematic. And allows for easy comparison of results. So the heading, it must have headings written above the table, so that describes what the table is about, and columns and rows with appropriate headings. Now, something that is important to note is that when you're drawing up your table, okay, I want you to think of the first column as your information that's going to go on your x-axis. So that's your independent variable. Okay, so that's going to be in the column that's running down your table. Okay, and then across in the top row, you're going to have your dependent variable. So what you're actually measuring in this investigation. So making sure that you set up your table in that way. The next is graphing, and these can be generated after information has been tabulated, and it's a good visual representation. And remembering that on the x-axis is your independent variable and your y-axis is your dependent variable, and that will make sense once you've drawn up that table with that x and y axis in mind as well. There are different types of graphs, and you can see here that different data has a different graph type that it's related to. Okay, we're mainly working with line graphs for our data that we've collected, but remembering that we can use column and pie graphs and scatter plots should that purpose arise. When we look at a line graph, what we can actually do is look at trends that are visible in that graph. And usually it's written in that format as written down the bottom. So as the independent variable, then we're going to use a verb. The dependent variable then does something else. So on the right here, I've included some verbs that we might see. Okay, and if we use an adverb, it means that verb be more specific. So as the temperature increases, the seasons that does not make sense at all. But you can see here that if you look at your examples, so we can say dramatically increase or minimally decrease. So really making sure that we're using using those verbs and adverbs in a really good manner. So we can see here that by using that terminology, we can actually describe the trends that we're seeing in our data. So a scatter plot looks like that if you haven't seen it. Okay, and it's used to usually determine whether there's a general cause and effect relationship. And another word that we associate with graphing is our line of best fit, and it's drawn to represent the general trend of the data. And it can be straight or curved depending on what pattern we see there. And then we have our column graphs. Okay, we can use two sets of data when we're looking at our column graph, same as we can do with a line graph, and then that requires a key. And we also see that key on the right-hand side with our pie graph, looking at our percentages. And visual representations can include anything like images and drawings as well as our graphs. Okay, they can be from the microscope or out in the field, which we're looking at, and they usually are able to show comparisons between different things and different parts of the investigation. And then we have digital representations where we can use simulations and models. And we usually use these representations when something is difficult to explain. And the last bit of our video here today is about outliers. And we usually use the line of best fit to see whether the variables are in fact related to each other. Okay, so the closer the data points are to the line of best fit, the greater the chance that the variables are correct. And an outlier is usually indicates an error, okay, and it can skew the line of best fit and reduce confidence. And in this instance, it's most common to remove data outliers as they occurred as a chance error. And we can look at our R values, which we looked at which we'll look at again later in our module for seeing whether the correlation between our data is there as to whether we actually include or exclude that outlier. So here we can see this correlation value, okay? And when this correlation value is calculated, we can actually, it indicates the confidence in our results. So we're looking at this bottom row here. That's really what we want our correlation value to be. Okay, and that allows us to have large confidence in our results and that there's a relationship between the variables is statistically likely.